Today we are going to discuss about differential equation of first order and of degree higher. So this is the part of the differential equations. So already we know the differentiation. So what is the meaning of differentiation? Means the rate of change of one variable with respect to another variable, that is called the differentiation. So here differential equations. So before that we have to learn what is the order. So order of the differential equation means the highest derivative in the differential equation is called what is that? Order. And what is the degree means the highest derivative power is called what is that? Degree of the differential equations. Today we are going to discuss about the differential equation of first order and of degree higher. So when we can say that equation means if the differential equation in the form of dy by dx whole power of n and a1 of x comma y dy by dx whole to the power of n minus 1 and a2 of x comma y dy by dx whole power of n minus 2 plus so on an of x comma y equal to 0 is called what is that? First order and higher degree differential equation. See, let us see in this equation, is there dy by dx, dy by dx and dy by dx. There is only first order, but let us come to see the powers n, n minus 1, n minus 2. But we are taking that highest power. So here n comma n minus 1, n minus 2, what is the highest power? N. So this we can say that first order and higher degree differential equation. So here in this chapter we are take the one notation, that is dy by dx equal to p. So please remember that one, p is nothing to what is that? Dy by dx. So in place of dy by dx we are write as a p. So then the equation is become p power of n, that a1 x comma y p power of n minus 2 plus a2 of x comma y p power of n minus 2 plus so on an x comma y equal to 0. So let us take as this is equation 1. So let's see this equation 1. This is totally in the terms of what is that? X, y and p. So that we can write as a what is that? It is a function of x comma y comma p equal to 0. So let us see the equation 2. So equation 1 we can write as a, this is a function of x, y, p equal to 0. Now let us come to that equation 2. So that equation 2 is solve for, there is 3 variables are there, no? So we can solve for p and the solve for y and solve for x. If there any equation, it is in that in one variable we can solve for only one variable, but this is in the 3 variables, no? So the equation is going to what is the solve for p and solve for x and solve for y, solve for x. Now first let us learn about that equation solve for p. So already just now we discussed about that this equation 1, p power of n plus a1 x comma y p power of n minus 2 plus a2 x comma y p power of n minus 2 plus so on and an x comma y equal to 0, no? Now this is that nth order, nth degree first order differential equation, no? See, this is that n power, no? So this first we are making that the LHS part of the equation 1 can be resolved into n first degree factors. So that equation 1 we can write as a p minus f1 of x comma y and p minus f2 of x comma y, so on p minus fn of x comma y equal to 0. First we have to make as a factorization and then we are going to equation solve for p. So this is nth order, nth degree, no? So we are getting that n factors. So that is, and after that the equation is solved for p with n solutions. So by solving the following the nth first order equation. So after solving these equations and we are getting what is that? P equal to f1 of x comma y and p2 equal to f2 of x comma y and so on p equal to fn of x comma y. So these are n equations. So we are solving that each equations and we are getting what is that n solution. So again here p equal to we have to substitute dy by dx, and using the any methods we can solve that n equations and we are getting what is that n solution. So if the n solution will be fn of x comma y comma cn equal to 0 and f2 of x comma y comma c1 equal to 0 and so on fn of x comma y1 and c1 equal to 0 for the n equations. But then the required solution is we can take an as what is that fn of x comma y equal 0 and f2 of x comma y comma c1 equal 0 so on fn of x comma y comma c1 equal to 0. But let us see here we are discussing about the first order. So the number of constant in the differential equations, the number of constant in the differential equation depending on the order of the differential equation. So this is the first order, no. So let us go that constant will be only 1. So let us take the all the constant that c1, c2, c3, so on, cn we are taking what is that only c. So the general instead of that all the constant we are substituting c. So the equation can be written as what is that f1 of x comma y comma c and f2 of x comma y comma c and so on f1 of x comma y comma c equal to 0. So this is the method we are following that solve for p. So any equations first we are making as a factorization, then only we are going to that solve for equations. So let us go to the one problem, see the examples. The first problem p square minus px plus py minus xy equal to 0. Okay. So this is equation solved for p. The given equation is in the form of that f of x comma y comma p and that p square minus px plus py minus xy equal to 0. So first we have to make as a factorization. So equation we can write as a factorization. How we can that is become p plus y of p minus x equal to 0. So equation 1 we are writing as a factorization, then the equation 1 will become what is that p plus y of and p minus x equal to 0, a b equal to 0, that is nothing to what is that a equal to 0 or b equal to 0. So when you are taking that p plus y equal to 0 and we are getting that p equal to minus y, that is become equation 3, and next to p minus x equal to 0, no. So that is equation is become p equal to x, that is what is that equation 4. So let us see that equation 3 p equal to minus y, and we know already that what is a p is nothing to what is that dy by dx. So dy by dx equal to minus y. From there we can write what is that using the variable and separable, that y terms one side and x term one side, then we are getting dy by y equal to minus dx. Now we are doing to the integrating and both side, and the integration of 1 by y dy is we know that log y, and the integration of 1 into dx is nothing to what is that x. So already here minus dx is there, no, that is become minus x and constant. So log y equal to minus x plus c. So when you are sending to log is the right side, then y equal to what is that c1 e power of minus x, and similarly that y into c power of x minus c1 equal to 0. So when your e power of minus x is sending to the left side, that is become y into e power of x minus c1 equal 0 when we are solving the equation 3. Now let come to the equation 4. So in place of again p dy by dx, no, so dy by dx equal to x, and using the variable and separable, and we are getting dy equal to x into dx. So now similarly we are doing the integrating, that integration of dy equal to y and integration of x into dx is nothing to x square by 2 plus c. Now after simplification that equation, and we are getting what is that x square minus 2cy plus c2 equal to 0. But this is only first order, no, but we are getting two constant, that is c1 and here the c2. So taking c1 c2 equal to c, then the equation, then the general solution of the equation can be given as what is that the product of the first one is y minus e power of x minus c1, and the second one is x square minus 2y plus c equal to 0. So this is the one of the example of solve for p. And next similarly that example 2, and the based on solve for p, 4y square p square plus 2xy of 3x plus 1 of p plus 3x cube equal to 0. So, that every problem first we have to make as a factorization. So, if we are making as a factorization, the problem will be easily we can solve for. So, this is solve for p no. So, first we have to make that equation as a factorization. See, let us see in the first two terms of that equation we are taking 2yp is common. So, if we are taking the 2yp is common, then we are getting what is that 2yp plus 3x square, and in the next two terms we are taking that x is common, then we are getting 2yp plus 3x square equal to 0. So, from there we can write what is the 2yp plus x and 2yp plus 3x square equal to 0, and similarly that ab equal to 0 we can write a equal to 0 or b equal to 0, and we are getting 2yp plus x equal 0, and we are getting p equal to minus x by 2y, that is equation 2, and next 2yp plus 3x square equal 0, then we are getting that equation 3, that p equal to minus 3x square by 2y. Now, let us come to for equation 2. We know that already what is the p? P is nothing to dy by dx. So, dy by dx equal to minus x by 2y. Now, using that variable and separable, again we are getting 2y dy equal to minus x dx. Now, do integrating on both side, and we are getting what is that integration of y dy is nothing to y square by 2. So, already here 2 is there, 2 to get cancelled, and we are getting y square, and x dx, that is nothing to x square by 2, that is we can take the LCM of 2, then we are getting 2y square plus x square plus c1 equal to 0. Now, come to the equation 3. So, in the equation 3 also in the place of p, if we are substituting dy by dx, so dy by dx equal to minus 3x square by 2y, then 2y dy equal to minus 3x square into dx. Now, again, so ab equal to 0 no. So, from there we can take a equal 0 or b equal 0. So, when you are taking that a equal 0, then we are getting equation 2, that p equal to minus x by 2y, and when you are taking 2yp plus 3x square 0, and we are getting that equation 3, p equal to minus 3x square by 2y. Now, let us see the from equation 2. Already we know that p equal to what is the dy by dx. So, dy by dx equal to minus x by 2y. Now, using the variable and separable, and that we can write 2y dy equal to minus x dx. Now, doing the integration on both sides. So, when you are doing the integration on both sides, y dy integration is y square by 2. So, 2 to get cancelled, and we are getting that y square, and x dx. So, x dx integration is x square by 2, and that already minus is there, that is minus x square by 2 plus c. So, when you are taking to the LCM, then finally we are getting 2y square plus x square plus c1 equal 0. Now, let us see the from equation 3. So, equation 3 is what is that? P equal to minus 3x square by 2y. So, P equal to dy by dx. So, dy by dx equal to minus 3x square by 2y, and now using the variable and separable, and we are getting 2y dy equal to minus 3x square dx, and 2y dy integration of y dy is what is that? Y square by 2, and 2 to get cancelled, and in the same case x square integration. So, using the integration of x power of n dx formula, that is x power of n plus 1 by n plus 1. So, that using that formula we are getting that x square dx integration is x cube by 3, and 3 get cancelled, and finally we are getting y square plus x cube plus c2 equal 0, and these are the two solutions. But this is the only first order no. So, instead of c1 and c2, then we are taking the only one constant, that is c. So, c1 equal to c2 equal to c. So, then the general solution of equation 1 we can write what is that? 2y square plus x square plus c of y square plus x cube plus c of y equal to 0. So, this is the problems of solve for p, and next go to solve for y. So, in the same problems here, the solve for y equation solve for y means, so when we are going to that solve for y means, so let us see that one problem, the solve y plus px equal to p square into x power of 4. Let us see this equation. So, observe that one, the degree of y is what is that? 1. So, in the equation the degree of y is 1, then we are going to that equation solve for y. So, y plus px equal to p square into x power of 4. Let us see here in this problem, that the y is in first degree. So we are going to that is that solve for y. So solve for phi means, so first we are going to what is the differentiation of given differential equation with respect to x. So when you are doing the y differentiation with respect to x, that is become dy by dx. So dy by dx is nothing to p and px. So here we have to apply the uv formula. So when you are applying to the uv formula, and we are getting p plus x into dp by dx. Now let us see in the right side doing the differentiation with respect to x, and p square differentiation 2p and x power of 4 is as it is, and p differentiation with respect to x dp by dx plus, and in the 4p square into x cube. Why? Because here x power of 4 differentiation is what is that 4x cube, and p square is as it is, that is 4p square x cube. Now same we are sending to that all the term to that left side, and taking that x dp by dx is common, and we are getting 1 minus 2p x cube, and the next two terms we are taking the 2p is common, and same we are getting 1 minus 2p x cube equal to 0. And in the two cases, what is the common? That 1 minus 2p x cube is common, and we are getting 1 minus 2p x cube and x into dp by dx plus 2p equal to 0. So in the same case, a b equal to 0, then we are writing a equal to 0 or b equal to 0. No? So in the same case, that 1 minus 2p x cube equal to 0 and x into dp by dx plus 2p equal to 0. So 1 minus 2p x cube equal 0 or x into dp by dx plus 2p equal to 0. So let us take that x into dp by dx plus 2p equal to 0, and here using that variable and separable. So same thing, that we are getting dp by p plus 2 into dx by x equal to 0, and do the integration, then integration of 1 by p dp, that is become log p, and integration of 1 by x dx equal to log x. So log p plus 2 log x equal to log c. 2 log x, that we can write log x square. So log a plus log b, that we can write log ab, that is become log p x square and equal to log c. Both side log will be get cancelled, and we are getting what is that p x square equal to c. Then we can that p equal to, we can write from that c x square. So we got p value, no? So p equal to c x square. Then substitute that p equal to c x square in the given differential equation, that y plus px equal to p square into x power of 4. So in place of p, and we have to substitute that p equal to c by x square. So if we are substituting in place of p c by x square, and we are getting y equal to minus c by x square into x, and plus x power of 4 into c square by x power of 4. So that x power of 4 get cancelled, and we are getting c square, and x by x square value is x. So finally we are getting y plus c by x equal to c square. So here one more get is there, 1 minus 2p x cube equal to 0, and it's give the singular solution. So that's why we are taking that only x into dp by dx plus 2p equal to 0. So this is the one of the problem in solve for y. So in the same case, we are going to learn about next problem. This is also solve for p, and p square minus xp plus y equal to 0. So in the given differential equation, and the first degree in y, no, so we are going to solve for y. So when you are going to solve for y, first we have to do what is the differentiation with respect to x. So when you are going to differentiation with respect to x, and p square differentiation is become 2p, again p differentiation is become dp by dx, and next to minus xp differentiation we have to apply uv method. So when you are applying the uv method, and we are getting minus p and minus x dp by dx, and y differentiation is become dy by dx, that is nothing to p, that equal to 0. Now in that both cases, that pp get cancelled, here minus p is there and here the plus p is there, that both are get cancelled. So in the total common term is what is that dp by dx. So 2p minus x dp by dx equal to 0. From there we can get what is that 2p minus x equal to 0 or dp by dx equal to 0. So 2p minus x equal to 0 is give the singular solution, and then we are going to what is that dp by dx equal to 0. So now solving the dp by dx equal to 0, and using the variable and separable, then integration of dp is p, and 0 into dx, that is becomes 0. So 0 into integration, that is we are getting constant. So we are getting what is that p equal to c. So we are getting p equal to c. Now substitute that p equal to c in the given differential equation. So in place of p we have to substitute c. Then the equation is become what is that? Y equal to cx minus c square. So this is the problems about the solve for y. So already we finished the solve for p and solve for y. Next we are going to discuss about that equation solve for x. Okay, see here in the same way here the first problem is there 2p cube plus y by x equal to x. Now in that equation solve for y we are doing differentiation with respect to x, but here we are going to equation solve for x. No, now here we are going to do the differentiation with respect to y. There x and here y, we are going to solve for x. No, so we are doing the differentiation with respect to y. So next we are see that 2y cube plus y by p equal to x, then x differentiation is become dx by dy. So p equal to dy by dx. So in the same case the dx by dy is become what is that? 1 by p. So dx by dy equal 1 by p, and 2p cube differentiation is become 6p square. Again p differentiation with respect to y, dp by dy, plus next y by p, that is become, again we have to apply that uv formula, and we are getting 1 by p minus y by p square. Again p differentiation is dp by dx. So next if we are taking the dp by dx, here the both side 1 by p, 1 by p, the left side is 1 by p is there, and the right side is also 1 by p is there. So we can get cancelled. So after the cancellation we are getting 6p square minus y by p square of equal to 0. So it seems here also ab equal to 0. No, then we are getting the dp by dy equal to 0 and 6p square minus y by p square equal to 0. Now let us see the dp by dy equal to 0. So then case we are getting dp equal to 0 and the integration on both side, and we are getting p equal to c. So after getting that p equal to c, again we have to substitute in the given differential equation, and we are getting that x equal to y by c plus 2c cube. So which is the required general solution of the given differential equations. So what are the topics we completed? Means solve for p and solve for y and solve for x. So remember one thing, so when you are going to the solve for p, so we have to make that factorization. So that factorization is important. So after the factorizations, and we have to solve the differential equation. So after the factorization, in place of p we have to substitute dy by dx, and using the previous method. So not only variable and separable, and we have the so many methods solve for differential equation, like finding the integrating factor, and we are getting solve for differential equation, and we are using the linear differential equation in y and x, whatever may be that in the previous methods, what are the we are discussing, and we can solve for p. So but when you are coming to the solve for y, so one thing you should remember thing, if the when you are going to solve for y means first let us observe the differential equation. If the degree of y is 1, okay, so if the degree of y is 1, so then we have to go solve for y. So that is the important things. If the degree of x is 1, like means degree means that is the power of x or power of y. So if the degree of x is 1, then the problems is going to solve for x. So remember one thing, so when your problem solve for y means the first initial step we have to take, what is that? We are going to differentiation with respect to x, and in place of dy by dx, and we have to substitute in the p. So then the equation is turning into in the two terms, two terminologies, that is p and y, that is the completely. So then easily we are getting solve for equation. The three variables equation is turning into the two variables, that is y comma p. So when you are going to the solve for x, so first thing what is that? Let us see the degree of x is 1, then we are going to solve for x. So first step we are going to the doing the differentiation with respect to y. When we are going the doing the differentiation with respect to y, that is become dx by dy, but we know that dy by dx equal to p, then what about dx by dy? There is nothing to what is that? 1 by p. So in the same case, then the equation is turning into two variables. Now same we have to make the factorization, and after that factorization and using the previous methods. So what are the previous method? Using the variable and separable and finding that integrating factors, and solve the differential equation and using the linear differential equations, and we solve that differential equation. So this is the concept about that first order and higher degree differential equations. There are the three cases will be there: solve for p, and solve for y, and solve for x. So that is the important task. So solve for y and solve for x. So when we are going to solve for y means, so if the degree of y is 1 and we are going to solve for y, immediately after that we are doing the differentiation with respect to x. So when we are going to that solve for x means, the equation is solve for x means, then we are going to differentiation with respect to y and that dx by dy. So in place of dx by dy, and we have to substitute that 1 by p. So this is the differential equation of first order and higher degree. So this is the topics how we can solve that first order and higher degree means, this is the three cases: solve for p, and solve for y, and solve for x. So initially we are learning what differentiation. What is the differentiation? The rate of change of one variable with respect to that another variable, that is called the differentiation. And what is the differential equation means? If the equation is involving with the derivatives, so then the equation is called what is that? Differential equation. So there are two types of differential equation is there. One thing is ordinary differential equation, and one more is partial differential equation. The ordinary differential equation we write as a ODE. So what is the ordinary differential equation means? So in the ordinary differential equation, then derivative of one dependent variable and with respect to one independent variable, so that is called ordinary differential equation. And what is the PDE means? The derivation of one dependent variable with respect to two or more independent variable, so that is called that partial differential equation. So this is the main concept about that differential equation. And what is the order of the differential equation means? The highest derivative in the differential equation is said to be order of the differential equation. And what is the degree of differential equation means? The highest order power will be what is that? The degree of differential equation. So this is the concept about that differential equation of first order and higher degree. So this is the concept, and we are solving for y and solve for x and solve for p. This is the regarding about that first order and higher degree differential equation.